candidates, though, were really special. It completely reversed the trend that said that most exoplanets were these hot Jupiters. Now, all of a sudden, most of them are less than half the mass of Jupiter, and a lot of them, a great deal of them, are down at around Earth mass. Some of them that have been found were around 1.2 Earth masses, possibly even less for some of them. So basically, we've got another Earth out there, with one exception, which we'll get to. There's always an exception, but we're definitely a huge step closer. Now the trend of exoplanets is towards smaller planets. And in fact, because of these recent discoveries, the trend is that approximately for every time that you have the radius, you quadruple the number of planets orbiting the star. So apparently, according to this recent data, there are going to be more and more Earth planets even than large gaseous giants, large gaseous planets, at least in the interstellar system. That does not include in the outer stellar system.
Oh, so every time you cut the radius in half.
Exactly. You quadruple the number of planets.
Oh.
Yeah, go ahead.
So the new technology is equally as good at detecting large, like super Jupiters.
Oh yeah, definitely.
Earth-sized planets.
Exactly. And the reason, by the way, that it's in that big orbit, I'm sorry, that it's going to last that long, why it's a 3.5-year project, is that it wants to discover planets that are in an Earth-like orbit, meaning that they're far enough away from their star that they have liquid water on the surface, which if you're too close, of course, it'll all boil away. If you're too far away, it'll freeze, like on Mars. So that's why it's got that long thing. So it can see multiple instances of that planet in its orbit. But the really fascinating thing to me, what to me was the catch of this whole data release, is that this spacecraft has been out there for a year. And this data only represents some of the data from the first 33 days of operation. Now, how's that? So